Alright, this video is going to show how to correctly solve question 9 from exam 1 part B of the Finance 320 spring 2014 semester. First off, let's look at the question. Use Sharpe's single index model as a single factor to estimate expected returns and risk on a universe of 20 stocks and one market ETF. Assume your forecast for the market risk premium is 3.26. Other forecasts made by analyzing 262 weekly observations. Risk-free rate is 3.1%, and the risk aversion coefficient is 3.51. So first, we're going to go through, input everything we know, or they give us in the beginning. 3.51 risk aversion coefficient, 3.1 risk-free rate, risk premium is 3.26. So I've already done that. Now we are going to do specific scenarios. First one is find the minimum variance portfolio of risky assets that has a net exposure of 100%, a beta of 1.01, and no short selling. So this means that we're going to need a normal portfolio. Using the factor method, we are going to minimize risk with only positive weights. We're going to use the factor model with new premia, and then let's update it quick. Now we're going to use solver to add some constraints. Alright, so we'll go to solver. We have that, the net exposure equal to 1. We're minimizing risky portfolio standard deviation because we're minimizing risk. And then weights are greater than 0. And then we need to add 1. We need the beta to be equal to 1.01. So we're going to click on here, equal 1.01. Alright. We're going to hit OK. Let solver do its thing. Alright, it's found a solution. You got to keep in mind that solver isn't always 100% correct. It gives a very close estimation, so I'm gonna just put my answers on the side right here. So for this is the scenarios with 4, 1, 2, 3, 4. I'll get rid of this. Numbers 1, 2, 3. That's the scenario, and then we're going to be finding the standard dev, or no, expected return. And now we'll go returns and standard dev. So for this, we got 6.39 with a standard deviation of 22.55. Alright, so those are the answers to number 1. Expected return 6.39. Expected standard deviation 22.55. Alright, we'll go to the second one. We need to have an arbitrage portfolio that has net exposure of 0. That's arbitrage is. We got to find the preferred portfolio of risky assets that has gross exposure between 30% and 120%. No target beta, and of course short selling is possible. So we're going to go normal. This is going to become an arbitrage portfolio because it tells us it wants arbitrage. You use the factor method again. So we're going to maximize utility, because I believe it said optimal. Arbitrage preferred, so that means optimal, which is maximize utility. We're going to go any weights, because it has to have 0 weights. Short selling is allowed, and it's an arbitrage opportunity. That's still using the factor model with no premia. Risk aversion is 3.5, and risk rate. Update this quick. Alright, now it's done. Net exposure is 0. We're going to use solver to make sure gross exposure is between the, I believe it was 30 and 120%. Yep. So we'll go solver, gross maximize utility, changing weight. I'll add gross exposure 1.2, and then gross exposure again greater than or equal to 0.3. Hit OK, and we'll run that. We'll solve. Found a solution. Return 0.46. Standard deviation 3.61. We'll see what it's asking for. 4.43 and 3.51. That variation will be in because of solver can't be completely exact, but it's pretty right. We'll go scenario 3 now. Let's see, what's it asking for? Sometimes investor imposes position size. Assume the investor cannot include the riskless asset in her portfolio. She has no specific target beta. Position size must be between 0 and 7, and she wants to be fully invested. That means net exposure of 100%. Optimal portfolio will have an expected return. Alright, so we're going to go here. Normal portfolio, factor method, maximize utility still, positive weights. Alright, we'll update this. So we have a net exposure of 100%. We just need to set some parameters. We need to make sure these, oh crap, sorry. We're maximizing utility right here, max. We're going to add some, these need to be less than or equal to 0.07. Alright, and then we'll add that, and then this one has to be equal to 0. Okay, make sure that's all we need. That looks right. We'll run solver quick. Alright, 5.62, 18.1. Beta they're asking for, as well as the utility. Beta 0.7718, with the utility of negative 0.13. Alright, percent this. Now we'll just make sure that those correspond to correct answers. 5.6, 5.62. Right. Standard dev 18.1. probably right. This is probably because of variation. Beta 0.7662 is right. We're very close to that. And boom, boom. Utility index 0.13. Alright, we'll do the last one quick. It's asking for a riskless asset. Same thing, except we're going to include the riskless asset this time. So we are going to accept. We're going to be maximizing the Sharpe ratio because we're going to be including the riskless asset. So we need positive weights, boom, maximize Sharpe ratio, factor method, normal portfolio. That looks good. Run it quick, update it quick. We're going to use solver again to constraint the size of securities. They're all going to be between 0 and 7, so only one constraint. All portfolio weights. Alright, we're going to solver quick. We're going to add this. Okay. Solve it. Okay. If I look at it, we need to know the complete portfolio. So her new optimal portfolio will have an expected return of 3.68, standard deviation of 20.20, a beta 0.8810, and a oh, sorry, put that in this is utility of 3.39%. And the weight, oh yeah, the beta, we have to solve beta. It's gonna be, this is our beta for the whole portfolio, but we need to know what it is for just the risky asset. We need to multiply it 0.8810 times the weight of the risky asset, 20.20. 0.177962 is our weight, is our beta, and type this one in wrong. This one is actually 4.07%. Just looked at the wrong cell. Right, standard deviation point. That's close. Probably off just because of solver. Beta's close. Off solver. Utility index 3.39. Alright, and the last one it asked for was the weight of the riskless asset. So this is easy. The weight of the risky asset was 20.20%, so we're just going to subtract. We're going to go 1 minus 0.2020, and we get an answer 0.798%. That's close, probably off again because of solver. That's how you do it. We're done.